Hello and welcome back. As I said in the previous video, we are continue filling out our little table here. So this notation here stands for the x numbers which are bigger or equal to a, and this is a closed type interval, and we draw it like a dot here which represents a, and then the interval itself is the bigger numbers than a. Okay, so these numbers. Okay, now let's see some examples just to make sure that you understand what I'm supposed to teach you. But I need more space for them, so I'm going to remove this. Let's say the first example as 2x minus 1 is smaller than x plus 3. So now you should pause the video and try to make it yourself, but I'll tell you the solution. So the solution is that you have this inequality, and then you add 1 to both sides, then you get 2x is smaller than x plus 4, and then you just simply subtract x from both sides, and then you get x is smaller than 4, and that is the solution for this inequality. Let's see a bit harder one, that 6 over x minus 1 is bigger or equal to 5. Now the inequality 6 over x minus 1 is bigger or smaller is bigger or equal to 5 can hold only if x is bigger than 1. Why? Because otherwise 6 over x minus 1 is undefined or negative. Therefore x minus 1 is positive, and the inequality will be preserved if we multiply both sides by x minus 1. And we have 6 over x minus 1 is bigger or equal to 5, and now we multiply by x minus 1, and then we get 6 is bigger or equal to 5x minus 5. Just simply add 5 to both sides, then we get 11 is bigger or equal to 5x. Now you can divide both sides by 5, and then you get 11 over 5 is bigger or equal to x. And now you might say that this is the solution. This is our solution for this task, but no, because you need to notice that that x must be bigger than 1. So you should write 1 here, and that is the solution for this task. As using the interval notation is an open interval from 1 to 11 over 5 with a closed notation here. Now I'm going to talk about the absolute value. So the absolute value of a number x, denoted by these two lines here, is defined by the formula that the absolute value of x equals to x if x is bigger or equal to 0, so it's non-negative, and minus x if x is smaller than 0, so it's negative. Now find the absolute value of 3. 3 is a positive number, so the absolute value of a positive number is itself, so it's 3 again. Now let's see the absolute value of 5. You can see that minus 5 is a negative number, so the absolute value of minus 5 is the minus 5, and you know that minus 5 is 5. Okay, since the symbol square root of a always denotes the non-negative square root of a, and So we can have an alternate definition of the absolute value of x that so another definition for the absolute value of x is that the absolute value of x equals to the square root of x squared. It's important to remember that the square root of a squared is the absolute value of a. Don't write that the square root of a squared equals to a until you already know that a is positive. Okay. So that's how you deal with the absolute value. Now, there is a final example for you, but I need more space again. That solve the equation, the absolute value of 2x minus 3 equals to 7. So you might remember the definition of absolute value. So that this means that 2x minus 3 can be equal to positive 7 and minus 7. So there are two equations. The first equation, that 2x minus 3 is 7, and the second equation is 2x minus 3 is minus 7. So there will be two x's. So there will be two solutions for this problem. Okay, so this is the third problem. And then, okay, just simply add 3 here. So 2x equals to 10, and then divide it by 2, and you get that x1, so the first x, is 5, and that is our solution for the first equation. And for the second equation, we just simply add 3 again. So 2x equals to minus 4, and then divide by 2, and then x2, so the second x. So the second solution will be minus 2. I hope you understand these things I've been talking about to you, and thank you for watching my video. I hope you enjoyed. Bye bye.